You know, I know you guys are going to laugh. This is the Spitfire 3 taper. I sit out here constantly and just take a plane out and just sit here and stare at it. Shows you what illness these Reno air racers bring upon us. Anyway, we're going to get down there and back to working on a Spitfire project. Now, there's a valid point to all this, and of course the point is if you're really not totally wrapped up in your modeling, if you don't love the models, if you don't really not care how long things take to do or what they cost, if you're totally dedicated, totally crazy, I guess is the right word, you wind up somewhere in your life, somewhere further down the road, and I'm 50 years old, you wind up with an Air Force. And this is my little Reno Air Force, and I hope pretty soon I'll be starting my, well, Joe and I, the RAF Air Force, but you have to somehow look into the future and see that this is what you'll have in your backyard someday. Next job on our illustrious, whatever you want to call it, Spitfire construction project. Yeah, I've taped on the wingtip similar to the way we installed the other tip. A couple of tips, and I've done this, believe it or not, this is not funny. I got the tip on and didn't realize I had the lead outs running through the wingtip crooked. I had to cut it off and move them around. It's really a pain. Again, I want to get this nice and lined up. And Joe did a beautiful job of matching this. He left it just big enough oversized. I can carve and sand this right in. Just get a couple of dots to hold this on. Look at it from this back. Okay, that looks good. Once you're happy with it, it's so much more work doing this than a typical straight line stunt ship. But I don't know. I think it's worth it. I hope it is. I hope Joe thinks it is. Hey, if we win the war, it'll be great. Anyway, I just jury rigged up another thing here in the shop. I have my cable system jury rigged up now so I can record Wings every night. I'm going to start to make a full collection of the Wings episodes. So anybody out there that likes Wings, and if you're missing an episode or you haven't seen one, what I'm hoping for, of course, is that there'll be a Spitfire Wings. That's what I'm doing it for. I spent $50 for cable parts so I could record the Wings. And they better have a Spitfire issue, that's all I have to say. Okay, that looks good. Now this is a little more work than the other tip because I have to work around the lead outs. So I'll try to, well, what I'll do, I'll get this roughed in. Just trying to blend the sheeting in real nice. Again, every part of doing one of these type of wings just takes considerably more time than doing a straight line wing. Getting all the angles blended in. Probably could make a new Spitfire quicker than this. Well, one of the things I'm trying to do is keep the same thickness at both tips. I don't want to have this tip be any thicker or any different in shape, so I'm just doing this by feel. Feels a little thicker in here. Just trying to take off some of the material, and then the last thing I'll do is get the joint in flat. I'm going right up through but not over the joint. And the last thing is I'm trying to just get the seam so you can't feel it with your raw hand. This is a convex curve that works its way up here, so. Now the only thing Joe could have done to make this better was use a much softer block. This block is harder than the sheet, so it's definitely a high skill level thing to get a nice match. Constantly looking at it from the front to maintain that shape. And the last thing I'll do is get some 320 and just put a final nice matte finish on this. Now the best way I know of to get this any seam really to disappear is just use your hand. Just eyeballing it will not be enough. And I see I still have to reverse curve this some. It's just such a pain in the ass with these lead outs in the way, but no realistic way to avoid this. Really spending all my time to get this reverse curve, because once this is painted, you'll definitely see all the reverse curving just like you'll see on an open bay. It'll take some time and effort, but I'll get it. And I want to get that the same thickness again out as the other tip. If you're not sure doing it by hand, you could make a little gauge, just a thickness gauge, so that they were both the same.
A cannon mounted on top of the engine that fired through the propeller hub.
Now it just seems like it's taking a lot longer than it should. A couple little spots here. I'll try to get these on a macro lens. Where the wood isn't a perfect joint, I'll just hit that with some DAP, of course. Is this great anyway? Look at this. Check this out. Wings being recorded as we build. I can watch it over and over again. Can't wait for Spitfires on that. Anyway, we got one done. I'll try to get the other one done. Well, I'm not going to get much done later time. Maybe tomorrow I'll come back and work on this some more.
In the 1930s, the 109 was an aerodynamic marvel.
Now, before I call it quits for the night, I'll just put the slightest little bit of DAP on here. This can be drying overnight, which will be nice. And we'll pick this up tomorrow. I'll get the other one done, and boy, it's really starting to shape up. I want to get those edges where I've blended these in. That quick wipe with the towel make sanding job a lot easier tomorrow when I come back to this. And of course the trailing edge now, I have all of the edges on this one wing. So I want to just keep going over and over them. Every time I sand something in, I just maintain that edge. And especially out where, ooh, that's smoking right up. Out where the tip, that very edge right where the tip is, that's very delicate, so let me get some thin CA right on there. Whoop, see, you don't move the paper towel fast enough, that's what happens. I'll let this cook up and get the other one done either tomorrow or whenever. Okay, finished. Away to dry now. One wing in the bank. Only need that one joint there to sand out tomorrow, and then I can start on the second wing. Now today in the shop I'm doing a repair on this stiletto. One of the things is there's a big patch that was on this wing from years ago. We're going to try, and this is the reason I want to put this on the video. We're going to try again using this to do repairs. This stuff works so good. I'm really impressed with this. Anyway, the first part of anything is I've masked off all the areas that are not going to get touched up. I'm going to grind this all down with 400 and some M600. Get it all laying nice and flat. You can see this side is still in the paint, the original paint. That side actually isn't too bad, but this side had a big hole in it here that we repaired last year. And what happened over the course of time, the red nitrous stain sunk in, and so this is time now. It's, you know, the flying season is basically over. Where we want to get a nice repair on this. So let's see how this green stuff works out. Now, as part of the Spitfire project, what the hell's the M600? We're trying to, one of the things we're trying to do is develop some new materials and some new techniques. This, of course, is the Sickens M600. And anytime you're going to repair anything, whether it's something that's oil-soaked or actually fresh paint that hasn't been ever exposed to oil, sanding it with the Sickens M600. This is some 400, just roughing it up. You can't put the green putty on top of shiny paint. It's got to have a rough texture so it gets a mechanical tooth. So obviously step one is we'll get some of this in here. Sand away, get it a dull matte finish, and then we can trowel in the first coat. And it isn't a whole lot different than doing ordinary body work. You go down to a body shop and watch them, you'll see they're using this, probably the same material and pretty much the same technique. And I don't want to put any more of this on than I really have to. And boy, a little bit really goes a long way. The big advantage of this is it dries so fast. I think within 10-15 minutes this will be dry, and certainly if you put this outside where it's a little bit warmer than it is in here in a damp cellar. Now there's also a repair out at the tip here I want to do. This almost has the smell of Bondo. It just gives you that same, but whatever it is, it really seems to work well. And now the whole idea is while this is drying, I can go work on the other wing. A little ding over here too. As long as you're doing this, you may as well bring it right up to snuff. It's amazing to me how many people have a beautiful plane and just let it go downhill, when if they're going to do a little repair, you can bring it up to just like repainting a car. It can be a brand new, this can for all purposes be a brand new plane. And we hope next week Don's going to take some time off, and this plane actually could be trimmed out. It's ready to be trimmed. Okay, we'll let that dry. Now this side here is in a little bit better shape, but it's still going to require some sanding, so I'll do most of this off camera, and we'll get back to this when we're ready to do the final finish. Now it only takes about 10, not even 10 minutes for this to dry, and you can see this feather edge is in, block sanding it out wet with Sickens. This block sands out beautifully. This is really a nice material to use, and we're going to be doing more with this on this whole series of videos. Every chance we get, we'll be trying to use this. This really makes repair work a lot easier than with the red nitrous stain, that's for sure. Again, if you're trying to fill in a valley, the best thing is just put it on in very thin layers. Block sand it out like I'm doing. If you can sand over paint, sand it wet. And you know it's sanded well when you see the edges, the feather edges. The edges have to be feathered. That's the whole key to a good job. Keep it wet. And again, this will probably save you a lot of work. If you go to repair with the red nitrous stain, this stuff is, believe me, a lot better. Let me just get a little look at this. See, on the Macklins, it's that feather edge. When you see that edge where it just disappears, feathers out, you know that's perfect. That'll be a perfect repair. Now, there's nothing to keep you from doing this 3 or 4 times. If there was a low spot, and it feels like right here there's a low spot, I'll put on a second coat. Great material. Got to use this stuff. Sands out beautiful, doesn't it?
Yeah.
Amazing. Keep it wet. When you wanna, you can't let it get dry. You just gum up the sandpaper. Don is in training for the Body Shop of the Month award here.
Woo! This stuff comes out.
Get it nice. Get it nice.
Forget about it.
You want to be the Pavarotti of body work, you got to pay.
Forget about it over here.
Actually, you can see this wing is on like the 3rd little thin pass here. He's on the 2nd pass out in there. Just a question of feather. You got to see a feather edge all around. Once you see a feather edge all around, you're in Fat City. The rest will be beautiful. You'll never see it when it's done. So what I did is I moved the tape back, peeled up all the old tape so I get a nice fresh new tape. The M600 kind of gets the edge real gummy. It has all nice new tape. It's wiped down with M600. And actually we're ready to start spraying it. Well, I get the first coat of black on here. We'll get 2 coats on. That green stuff is just amazing. Just amazing. Anyway, Don went up to get some pizza. We'll let this dry, get a second coat on, and once he's gone, we'll go back to working on the Spitfires today. Today we had a real good session in the shop. Did a little repair job today. Talked to Frank McMillan, and I mentioned to Frank McMillan about this, and he said he was going to try it too and possibly mention it in his column. Pass the word on. If he can use it, I really hope that's going to be one of the things that make our repair jobs a little bit easier anyway. All right, anyway, I feel like there's 400 wingtips on these planes. I've been sanding and carving wingtips for the last, it feels like about forever. Anyway, I noticed this one, and what's funny, I was sitting at my desk. This one isn't carved or sanded yet. I looked from the front and I saw this one really has a little bit of a bow in it, and when I came and felt it with my bare hand, I said, ooh, wait a minute. In fact, I'm going to show that. Let me flip this around and show it on a video. One side actually, and probably I can't blame Joe for it, probably Joe carved it. It feels good until you put your hands on both sides and do this. And when you do that, you say, wow. Ooh, you can feel this. The bottom is a lot more of a radius. This is kind of flat. This isn't. So I'm going to spend some time and get this all knocked down. And again, one of the things that I've done over and over again, I guess I'm getting good at it, I don't know. When I'm all done, I kind of run both hands because we can't, this is a reflex curve here. And it really is difficult. What makes it even more difficult is the fact that this block is harder than this. We're going from hard to soft. So a suggestion is, and I probably mentioned this already, if you do anything like these kind of wingtips, Bucks, Deluxe, Spitfire, get the block, even the outboard block, as punky soft as possible so you can get that contour in there. So this makes it so much harder when it's a hard block. Now, I don't know if you're going to be able to see it on the video, but try to get right in front of it. That one is perfect. Okay? Now we go to the other one. Again, I'm doing it. This probably is something that'll play. Now see how it bubbles up out at the tip? Let me get right in front of this. It kind of goes here and then goes whoop. But you can feel that with your hand. The important thing here is always to do all carving or most carving with your fingers. Feel it. Feel it. People that do sculpting do all of the finalizing of shapes by hand. Your hand is much more sensitive than your eye. Now you can even see this bottom curve up in here is less than the one on the top. So I'm just going to work this out with the sandpaper now and constantly feel it by hand to see where I am. It's really just time consuming. Feeling it spends a little more time. Because boy, if I turn this wing back over to Joe and it's just even out by the thickness of a razor blade, he'll throw it in my face, kick dirt in my face, and I don't know, throw me in a pool or something, who knows. Look at these cute pajamas I bought for my stepdaughter. Now look at this cute. Am I a good stepfather or what? Oh man, I can't wait till she gets them tonight. Cute. This is a true confession because Wendy's been so mean to his stepdaughter. He's buying her pajamas for Halloween. Believe it. Anyway, I'm going to finish this wingtip here. It is just time consuming getting these guys in order. Now I want to show this up on the camera. I have one side of this velvety sanded in perfectly. You can see the bottom. I'm choking us. The bottom still bellies out, so you might be wondering to yourself, and I guess this is a good time to mention it, why would anybody spend all this time on one little detail that probably nobody's even going to notice, see, or appreciate? Well, there is a reason. You know what? I'll see it and I'll appreciate it. I know Joe Adamusko will. I know Ted Fancher will. I know Ski Dombrowski will, Steve Busso, whoever. People that go through this fanatical thing, and this is a good time to evaluate it for yourself. I'm tempted to rush at this point in time and say, let's get on with making horns and flaps, but I want to get each step as close to perfection as I can. And if you're not concerned with that, if you just think, well, you should just put on block wingtips and don't hollow them out or something, well, it's not, to me, it's not the same thing. Modeling is the kind of a skill you either love it or you don't, and you either do it or you don't, and Joe Adamusko and I agree totally on that. One of the things here is, I know there'll be some people that are going to come into appearance judging and just go just like that with their hand and feel that that curve is perfectly blended. And to those people, that's what I dedicate the rest of this evening to. I will finish this wingtip tonight. I'm definitely going to finish this. But it just takes so much time. And at a time when it does this, you have to kind of sit back and say to yourself, I really want this to be right. I really want it to be right no matter what. I just don't want to be done and whatever. I want it to be right. And that's what's going through my mind right now is I keep looking at this and saying, wow, how could it take so long to do that? Nah, nobody's going to see that. Nah, nobody. Yeah, baloney. People see it. I know Midgley will see it. Anyway, I'll finish the rest of this off camera, and that's probably all I'm going to get to do tonight. Alright, the little spackle in the low spots here is almost dry. And that's the last of the things. I just want to dust the spackle. And if it needs any more sanding than that, something is wrong. Anyway, I'm going to get ready to bend up the lead outs now. A lot of people have mentioned that I've, even out at the field or whatever, hey, how do you bend the lead outs like that? That looks pretty cool. Well, it is cool. And I'll show on the video exactly what my technique is. That looks good, and that was the only spot. See, this is another part of it too. It's just getting fussier and fussier. Now I filled in a little spot out here, and I'm going to need to put a second coat on it. I hope Adamusko is impressed with all this. He better be. That's all I got to say. Anyway, I want to bend up these leaders. That's close enough for now. Hate that word, close enough. Step one is, especially if you're using these lead outs from Scott Smith, these 48-inch guys, you want to get they have a coating on them. And you want to carefully get off all the coating. If you're using music wire from SIG, it usually doesn't have a coating. This has a rust-proofing coating on it. So you want to get most of that off, or all of it, before you do the soldering joint, that's for sure. And you want to get out a 1/4-inch drill, cut up a couple little pieces of the size fuel tank tubing, the kind that would go inside of a normal tank vent. Not the size of a tank vent, the size, next size smaller. That makes for the neatest little fitting. Now this is the material, what I was explaining. I cut off a few pieces of this. This is the size that fits inside of a tank vent. A drill that almost fits in the eyelets. You'll need a drill. and a couple of normal line wrap eyelets. Now step one is take the two little pieces of tubing, slide them up onto the wire, because, and believe me, you'll do it, is you'll put the bend on before the piece of tube is on, and I've done that myself, and then uh-oh, it's too short to cut it, uh-oh, a lot of problems. So the two pieces of tubing are on there. Now what I want to do is pull full up or full down, whichever the case may be, that'll make the lead out the shortest. In this case, I've got this one all the way in there. Leave myself at least an inch, inch and a half. Where the hell did the drill go? The drill is floating away. Take the drill, and using your finger as a fulcrum, just wrap it right around, almost a full turn. Okay, now it's obviously, let's show this up close. Okay, at this point in time, you should have a little bit more than a spring on it. Now, what I do is I take the needle nose pliers, and you don't want to bend this wire back and forth 15 times. You want to get it just past the point where the curve starts. Reverse the bend just a little bit. You want to catch it up here just before the bend. Bend it back just a little bit. Now what's a good idea if you're not comfortable putting these bends in is practice on a piece of scrap wire a few times till you get it to the point where you're real comfortable. The drill is the key to this, and knowing just how much to bend it. Now the next step is I want to trim this wire back just enough, maybe a little couple of thousandths less than that piece of tubing. Rid of that wire. Now I want to straighten this out, and usually that requires a little bit of bending to get this down because it forms like what it would amount to be a spring. Okay, so we have that much done. And I want to get me one of these little eyelets, just like the ones you use to wrap lines with. That's where a couple of practice little sessions usually work out well. I want to grab this through the eyelet, you know, if you can see how I'm doing this, through the eyelet and through the wire, and just bend it ever so slightly till it goes in there. Okay, let's show this up close. Just hang loose because this is the whole key to the whole thing. You'll notice it doesn't, let me get it up close. It isn't really all the way up there yet. Okay. Now I want to grab this with a plier, and I'm trying to do this through macro lens, so kind of work with me if you can. It's hard to do through the macro lens. Anyway, I think you get the idea. I need both hands to do this. You get the idea anyway. Notice the camera never leaves. Like I'm doing a magic trick here. Anyway, I'm just trying to pass this information on because I have seen some really sloppy, ugly lead-out guides on amateur planes, beginner planes. That presses that piece of tube right up. Now obviously we'll silver solder this, stay bright silver solder, and deflux it with baking soda and water. That's about the neatest way I know of. I don't know of any neater way to make a nice durable set of lead-out ends. It's just one of those more little details, little extra steps. If you're a modeler, you'll be impressed, and if you're not a modeler, you probably won't care. Now when you heat the solder, you want it to flow from one end of the tube to the other. Solder follows the heat. And you certainly want to be sure to deflux this with that mixture of baking soda and water. Seems like a small little detail, but hey, to some people every detail counts. Some kind of poem I remember from being in school The gods see everywhere. Jim Damerel sees everywhere. Always let the joint cool normally. Baking soda and water. You'll see the joint. This will kill all the acid off. And then I'll polish this with some 600 sandpaper and some Prepsol or whatever. Anything just to make sure all the acid is off. That black stuff you see on there, that's the acid that has all the contaminants in it. And it's always a good idea when you're done soldering, just thinking of things that are a good idea. Go wash your hands, because you go and eat something, you eat an apple or something, all of a sudden it tastes like solder and acid and everything. And unless you're a tough guy like me, you'll get poisoned. And one final story here before we pack it in for the night, and I'm just using some sandpaper to clean this up. A good friend of mine, won't mention any names, building a plane here, and he refused to bend the lead outs until absolutely the plane is all buffed out, and 30 seconds before he's going to fly it, he bends the lead outs. Will not mention this gentleman's name, but it was making me crazy. He'd walk around the shop in these big 9 feet of lead out, when knocking things over, poking people in the eye. It was making me crazy. I didn't want to hurt his feelings. But next time he comes here, and I'm going to send him out for pizza, and if lead outs aren't bent, what my feeling is, as soon as you get the wingtips on, bend the lead outs. Get one thing out of the way. One thing that can make you crazy. I remember Jimmy, when he had the long, flexible lead outs, and he'd leave them all curled up and shoved into the wingtip. And what would happen is, you'd buff the plane out or whatever, and take the lead outs out, and every time you flip the plane over, the lead out would go bong, 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 all kind of little dents and everything in a plane. Makes you crazy. Anyway, I'll just clean these up. Just one more of my little fanatical details. This is the way I like to do these. I know Joe Adamusco is going to love these lead outs. I have to sand my second coat of DAP out tonight, and that's going to be it for tonight. It's late. I've been working too late lately. I'm starting to talk to myself. Making me crazy. Joe, you're making me crazy. Now today, after that beautiful long night of sanding, by the way, I have both of those wings sanded out to perfection. Joe would be impressed. I just want to go through this. This is information you can use on any design. What we did in the past, all of the PMs, and this is all these ratios have been pretty much developed by Big Jim Greenaway. We wound up with a control system that basically was like this. And what I want to mention, the reason I want to say this is, this dimension was 4 inches. This dimension here was 13/16. Dimension here was 1 inch and 10 thousandths. This dimension here was 0.750. This dimension 750. What this resulted in was, let's just call it a 1-to-1 control system. What that means is, and let's just space this up, is as the flaps move, the same amount of degrees the elevators move. That's what's known as a 1-to-1 control system. Now last year, and I'll just make this Modesto, Rogers, Damerel. All made ships with, and I made all the horns so I know exactly what they were, a 4-to-5 control system. And what that meant is the flaps moved slightly less than the elevators. The elevators moved 5 degrees for every 4 degrees, and that was known as a 4-to-5 control system. And because this is all relative to a pattern master, I want to just clarify that this was a developed thing. All 3 of these ships had great corner. All use the standard bell crank and horns that I made up to Jim's specifications, and I have patterns for all those controls. If anybody wants a set, obviously give me a call. Now in the Spitfire, what I want to have is, of course, the standard bell cranks. I want to go up to and I have to make a special horn because it's going to have a longer than normal arm. And I want to come down to a flap horn that's going to have 3 adjustments. It'll have the 3 adjustments will be that the first adjustment here will be a 1-to-1 control system. The third one will be a 4-to-5 system, and the middle one, the second one, will be somewhere in between. It'll be a 9-to-10 system. If you can envision what the 3 choices would be with the push rod. Now, if you remember back to the old days, Billy Wurwood used to use a 3-to-2 hookup. The BJ was a 3-to-2 hookup. What that meant is the elevators moved 3 degrees every time the flaps moved 2. Now just keep in mind what the theory is here and what we're trying to accomplish. What we found out late in the season with Strega was that by replacing the bushing, which in effect, when you tighten up the bushing, and what we did is make it that would have a lot less slop, in effect what it did was increase elevated travel, and that little bit, just a few degrees of elevated travel, resulted in a much better corner. Now what I want to have on the Spitfire, I want to have a hatchback here on the outboard side of the plane. I'll figure out what the shape and size is going to be. And I want to have this horn adjustable to the 3 options. Now you might be thinking, well, yeah, a lot of people have sliders, including Tradition. Tradition has a slider. And you have an Allen screw with the bushing that slides up and down. Well, the reason I don't like that is the same reason I don't like a sliding bar on a handle. I don't like anything with a screw that can get loose. Even though this is a relatively safe system, a lot of people use it, I'd much prefer a silver soldered bushing. I just feel like then I'll have the choice of changing bushings, because what happens as the controls wear out, and we really do a lot of flying, as the controls wear out, I'd like to be able to get in there and replace that bushing without cutting the plane. And we're flying 52 gallons of fuel a year. That bushing in time wears out, even if it's lubricated. So we're going to eliminate, at least I am, the idea of a slider. I'm not going to use that, even though I've done that with Tradition, and there are sliders available on the market. This is the system I want to have. It'll be a 1-to-1, a 9-to-10, and a 4-to-5. There'll be 3 choices, and as we get into trimming the Spitfires, this will give us 3 distinct choices. Now I'm just going to assume here that everybody wants to make their own horns. You can obviously buy pre-made horns. As you can see, the genius of Joe K, we made up a stamp and stamp out 5,000 at a time. The material of choice, and we always save some little extra material, the material of choice is cold rolled steel, 1/16. I always save the pattern from the year before with, if I make any special horns, I have a pattern for each year plane. If they don't use standard horns, of course I'll do the same thing with the Spitfire. I've laid this out ahead of time as to how I want to have the controls. I've made up a template just to make sure everything was the way I wanted it to be. I have the tail piece made up in template. Now I have to actually go out and make the horns. And I figure I run through this. If you want to make your own horns, call me up. I'll send you some of these uprights for free. Drilling the uprights. This looks like it's a relatively simple job. Believe me, if you don't have the holes in perfect alignment, if they're cocked one to one side or the other, you can get yourself in trouble. I'll send you the uprights for free. How's that? No charge unless you want special uprights. Then I charge you $1,000. And again, record each plane, record it exactly what the ratios are, so you can always go back and replicate it at some future time. Now, unless you work in a place that you can buy cold roll steel, or if you just can't buy any locally, commercially, usually there's a minimum order if you buy it commercially, you can send to me and I'll send you enough to make your own control horns up. And I'll kind of walk through this, because one of the things, if you're going to make your own control horns, and I don't want to tell you how many horns I've had in the very beginning of making horns. I tried to do it with Stay Bright solder. Bingo, no good. I tried other ways of eliminating that braze joint. Forget about it. I tried using different material. I used material that a hacksaw blade is made out of at one time. It failed in service. Making control horns is more complicated than you think it is. So if you follow through with me, I think you'll be successful on the first try. First thing, you get cold roll steel. No matter how clean it is, and this is rusted up, you want to take some of that Scotch Stay Bright pad and get it nice and shiny. Get it absolutely shiny before you go on to the next step. Because when you braze this or solder it, it's a lot easier to clean the material now, clean all the edges. It's a lot easier to clean it now than it is at some future time. You'll have holes drilled in it, there'll be rough edges. Clean a whole piece. Again, the beauty of making up the uprights with a punch press die is they're accurate to within a 10,000th of an inch. They're all the same. You don't run into one horn being a little bit bigger. And I'll show what happens when you try to do it on a drill press without a jig. You can wind up with the holes all out of alignment, crooked. You can make yourself crazy, or you can wind up with some kind of crazy control system in a plane, and the plane won't turn equally, or it won't turn the way you anticipate or the way the designer anticipated. So getting it nice and clean is step one. Then I get one of these ink markers, or you can use the bluing agent. They make a material for bluing when you do machine shop work. An ink marker works just as good. Ink marker it, just put some ink marker. Let it dry a minute or so. Then what I do is take a piece of music wire, 1/8 inch music wire, get it to a razor point on a grindstone, and that's now a scribe, so you can put accurate lines on here for your drilling templating. Now, making your own scribe, a piece of 1/8 inch music wire, run it on a grindstone. Perfectly adequate scribe, you don't have to run out and spend $50. The material, of course, it's been just cleaned with the 3M pad. Now you'll notice one thing I can do with this, with the scribe here, I can put any kind of lines on here. They'll show pretty well. You can see how thin you can make a line. And that's what you want to be able to do. Now, of course, I made a template. I'm cheating here. I made a template already. So before I do anything, and I didn't get the holes in alignment yet. I'm not interested with if they're in alignment. I'm going to show this up close. Here's some of the problems you can run into if you're not careful. You can have, and I did this template on purpose, you can see these holes are not in alignment. But I don't care, because I have a drill jig that's going to put them in alignment. I only need to know the spacing relative to each other. And of course, having this template means that if I want to replicate this for a customer or just for another plane, I can go and do it. That gives me a relatively accurate spacing on the horns. Again, if I make another, and of course I have to make horns for Joe too, I can make them relatively accurately. Now, if you just come over to a drill press and you take your material and you just start drilling holes, they'll probably wind up walking all over the place. So a better way of doing it is if you have a template. Of course, you can always steal one from me. I have these that are done on a milling machine and a punch press, and I know they're exactly in the middle. So what I can do is take the drill out of the drill press, go to the back end of the drill where there's no flutes, run this down, tighten the drill up, I want to get this accurate, then I can loosen this, pretend this wasn't here to begin with, set this in position. Now that piece is in position now. Doesn't matter what the angle is because we're going to walk along it, and just make a little fixture. This will hold this in alignment. You don't need anything more sophisticated than this. You could even use the edge of the pliers if you wanted to. And what this allows you to do now is, as you want to drill holes, you can slide this down and every one will be in perfect alignment. And there's nothing more. If you have a milling machine, obviously you can do this with a milling machine, but if you don't have a milling machine, this is like a poor man's way to do it. You can get rid of the drill, put the drill in the right way. On this kind of an operation, I like to leave as little of the drill sticking out as possible. Don't leave the drill a foot long or it'll start to walk. The shorter amount of drill, the shortest amount possible. If you have to, you can take and shorten a drill. Now I have the piece that I wanted to drill. I have those rough lines on there. And I'll just make a test hole here. Now what I want to do is, with a micrometer, I want to see if I'm exactly in the center, and if not, I can adjust it with a little tap of the hammer. 18, 18, okay. Okay, it turns out I am relatively accurate because I used the fixture. So now what it means, I can just go back. I want to deburr a hole here, just so it slides along the table bed a little bit neater. Again, to make a nice set of horns, it's not just slap them in a drill press job. Each time you drill a hole, you want to just deburr it so you don't walk on a burr. Clean all the chips off the table. Again, without that little fixture, this would be an almost impossible job to do by hand. Okay, using a fine-tooth metal cutting blade. Doesn't that sound great? Makes your teeth feel so good. Now what I do next, to get rid of the square edge, take the drill, and using one of the horns that's been punched out on a punch press. Hey, why doesn't the drill fit in there? There it goes. What I can do is I can use this now for a pattern over on the grindstone, holding the drill in place, and I can just radius the edges nice. If you try to do this by eye, you almost always make a mess out of it. You can never get it really nice. So if you have a template and a grindstone, a nice fine-tooth grindstone, you're in Fat City here. Now once I get the rough cuts on there, I like to get the Dremel sanding drum. I just get this in my hand. It gets real nice and hot too. Real comfortable. Obviously you could wear gloves. Well, let me look at this up on a macro lens. Let's see if we can. See what I've tried to accomplish here is that they both have the same curve in them. You can take them off the drill. Now the last step for making up the uprights is to get one of those 3M pads out. Any grease or oil or rough edges. I just think it's a lot nicer if you can keep the rough edges to a minimum. Obviously, if you had some razor blade edges, as soon as you went to sand the plane, you'd catch your nose on it or something. A couple minutes now really pays dividends later on. Now I have to do the brazing joint. I have to bend the wire, do the brazing joints, figure out the spacing of the wire, do all that stuff, and then the last thing is I'll put the bushings in. See if you can put this on a macro lens. Okay, we got the uprights made up, and I'm going to bend up the wires and stuff tonight when I get back from work. We'll pick this up later on tonight. Now, I just got back from a day of work, and just quick, take a minute with me. One of the things I enjoy, and obviously we're all in this together, maybe you do, maybe you don't. I've been subscribing since I built that train layout upstairs that I've shown on previous videos. Been subscribing to Classic Toy Trains, and I'll tell you, this time of year, we're coming up on a holiday season. Every time this magazine comes in the mail, I get all nostalgic looking at all the things in the magazine and thinking, oh boy, I wish I was young again, and my wife, you know, wishing I would stop being a baby and everything. But this is one great magazine. If you've lived the childhood with Lionel Trains, spend $1 and subscribe to it. It's a great magazine. Enough Lionel Trains after supper. Before supper, I want to get the horn wires bent up, maybe even get them brazed, get the horns ready. And the next step, once we have the horns made up, is get them into the wings. Hey! Bada bing! Hey, look who arrives! Bada bing! Now I have marks here based on where I know the wire bends I want them to end. Of course, this is the real cream of the crop wire bender here. It's a real piece of jewelry, but it's bent a lot. Probably bent about 2,000 horns already, so laugh all the way to the bank. I'm going to get the legs as parallel as possible here. Now I always check each one individually here with a 90-degree triangle, because we're going to make removable elevators and flaps right up into the point we buff it out. I want to make sure all the legs are 90 degrees. Also that they're both parallel. These are not parallel yet. It has to be bent just a little more in the vise. Again, you'll know it's right when it lays perfectly flat and when it's 90 degrees in both dimensions. And I always deburr this edge. Deburr this with the Dremel tool, because as you're sliding this on the tube that's going to be in the elevator on and off on, you don't want to chew that tube up or get it all oversized. You want a nice tight fit there. For sure you want to deburr totally deburr the edge that's going to go into the tube and the flap. Now what I'm doing, I'm just removing the material that just would be going along for the ride, leaving right at the end of the horn arm full thickness. That's where it's going to want to pivot from. But all along the arm I can remove some material. Obviously right back here it doesn't have to be 1/8 of an inch, it can taper. It needs to be full diameter right on the end. And in here it can be relatively maybe half the thickness, and I don't want to take anything from away from the bend. Judicious little removing of material. We can get a couple grains off each horn this way. Now it's funny when you see a box of horns like this. And those are just the flat horns. Elevator horns are in another box. When you see a box of horns like this, you think, yeah, these jump out of the press. When you pay $10 for a horn that's plated, the bushings are pressed in, there's a lot more work involved than what an average person thinks there is. So, appreciate it. Hey, buy me a pizza. Now, before we actually braze these, I take that Scotch-Brite pad, clean them all up real good. If you've never made a set of horns, once you make a set of horns, you'll have a real appreciation for how much time and energy goes into these. And when you see some of the junk that's on the market, I was over at the hobby shop yesterday, and John Misk showed me some $2 control horns. Rusted, corroded, not the right solder, bushings, no bushings, not even breast-in bushing. You spend 100 hours, 200 hours finishing a beautiful plane, and then, a horn fails in service. Not a good saving. I know that's not politically correct, but hey, if you're going to buy a set of horns or make your own, do it right. It's a part of the plane that needs to be right. It can't be a place to save a few dollars. Save a few dollars, you know. Don't buy your wife a birthday present. Something like that, but put good horns and good bell cranks in your plane. Seeing some of the, and what's really happened is I guess I was the first one that made 1/8-inch horns and made them commercially, I don't know. And I used to hear nonsense about, too expensive and stuff. Yeah, go buy the silver solder for $140 an ounce or whatever it costs now. Anyway, the things are polished up, we're ready to do the brazing. You need to use a real torch and real silver solder, not Stay Bright, real silver solder and real flux. And if you had the choice, soon as you want to let them cool normally, you don't want to drop them in a bucket of water or whatever, let them cool normally, and then take them and soak them in cold water for some amount of time until the flux comes off. Soaking them in water, either overnight or for a couple hours, the flux turns to a glass-like material. It's almost impossible to get off unless you know the trick of leaving them soaking in water. And then we'll pretty much have our horns ready. I hope. Now you can see some of the material I've removed here. Let me just make this an exaggerated. This piece now looks like this. This is where I've removed the material from here to about here. You don't want to remove any material here, but in here you can take quite a bit of the material away. You can probably save a couple of grains of horn if you really want to. You can also, but I don't like to do it because I'm not I'm not going crazy right now to get this down to the last silly millimeter. You can also trim these back a little bit. Some of the people that make horns leave these arms a foot long. I have no idea. Some people don't even bend them, in fact. So it gives you half of the thrill of making a horn yourself. Anyway, this is where you can remove some material. You remove no material from here. This part you want to leave totally solid, the bend totally solid. But this material here, this piece doesn't have to be 1/8 of an inch right here. And I always leave on the end this last little bit full diameter and thickness, because that's going to press inside the aluminum tube, and that's going to be where all the pressure of the horn is going to be, right on the back. Not much is going to be here. Most of it's going to be right at the back. You could even, if you really wanted to go fanatical, make this into an I-beam section, Dremel it out, grind it out, or whatever. But just removing some of this material. Also, what that does, it lets you, when you slide the tube on, once it's in a flap, let's pretend this was a flap here, you get a little bit of play so you can get the hinges lined up real nice. None of the hinges are under tension. So just one of the final things. Now ready to jig this up in our little fixture and get the brazing joint done. But everything is polished nice and clean before we do the brazing. Now it really isn't critical how you fixture this up. I just use the edge of a drill press. You want this to hang at a 90-degree angle. This is the flux. It's a water-soluble flux. You have to mix it. Again, if you've never brazed or never silver soldered, maybe you want to practice. Make some practice pieces, but certainly, you know, or you can make up your pieces and send them to me and I'll braze them. Then for sure they'll break. This real silver solder is very expensive. You'll be shocked when you go to buy some. I'm using MAP gas. Now the trick is with this flux, you heat the part. When you see the flux turn to a glass-like material, you know you're at the point the silver solder is going to melt. What happens then is you don't want to apply the solder until you actually come right down to where now it's just turning to glass. Now I'm going to put the solder on one side of the upright. Okay, it just worked its way down. Now as it melts, it's going to come through the other side of the horn because it flows toward the heat. Now you heat the side of the wire opposite of the joint. The solder flows through, it comes out the other side of the horn, and you know you have a good joint. You know that joint is bulletproof. Let it cool normally, just let it sit there. Now if it's a little bit tweaked one way or another, once it cools and you deflux it, you can bend it ever so slightly. If it's off a lot, just heat it with the torch and tweak it into position. I like to let this sit now, let it sit till it cools off, and then I'll dump it in a bucket of water. Now you can see that glass-like material. You can see it drips and drools. That's the flux. Now I'll just soak these. I'm going to go over to the sink and just soak them in cold water for an hour or so while I do something else. And then I'll clean them off by hand with the 3M pad and they'll be ready to put in a plane. Now I have the press-in bushings, and instead of using the Stimson press, which we normally use, I'm going to leave these just tapped in, put a washer on the other side, and silver solder them up using the Stay Bright. Do is, to get 3 bushings in here, I have to grind one with some flat spots on it. They just tap in there real nice. Your little flat spots. Otherwise I wouldn't be able to get all three. Now notice I always put these in so that the wire, the push rod wire, is going to ride on this side, so centrifugal force will be wearing against the brass. I want to have this end open so I can change the push rod when I have that little hatch in the back. Now the last step is I'm taking that Stay Bright, soldering the bushings in permanently. Let it cool and deflux it. Let that cool and we'll be all set. Now I always repeat this over and over. Never use Stay Bright solder and not deflux it. Especially this. Now one of the things I'm going to have to do here, some of the silver solder always winds up running inside the bushing, which is okay. I'm going to take a 93 thousandths drill, 3/32 clearance, run it through, and that'll give me right back to exactly the clearance that I'd like to have. Get all that flux off of there. Now what I decided to do here, and I tried this, it worked pretty well, is I reversed some 1/8 inch eyelets, the belt crank eyelets, onto the top of the horns so that I can have double thickness. Actually, it'll give me a little more brass in the bushing area. We'll see how this works. I want to see if this is kind of an experiment here to see if this works okay. Oh yeah, that works pretty good. Now I don't want these at the tail, I only want these up at the nose, up at the flaps right now. Because back at the tail I'll want to adjust the clearance by drilling them out. But up here I'd like to have, at least going to the belt crank, as little play as possible. Now just drilling these out with a 93 thousandths drill. Should be a perfect fit for 3/32 wire. Now you also want to just run a little bit of a countersink into each one of the bushings, because the wire that's going through here is going to have a radius, so if you want to maintain that real nice tight fit, you're going to need a little bit of a countersink to match the radius of the wire. A lot of little details go into having a bulletproof control system, awful lot of little details. But when it's right, boy is it right. Takes half of the pilot workload off. Now just one last little thing, gets a nice slow speed wire brush, put a nice polish on. Now if I had time, I'm not going to have time, I'd run these over to the platers, have them put them into plating. But I want to get on with this project tomorrow. And I'll usually keep this stuff 2 to 3 weeks if I leave it over there, so we'll have to live without the plating this time. It may seem like an awful lot of work, but if there's only one part of the whole plane you get right, get the control system right. God, if you nothing more frustrating than having a control system that wears out, the plane is in perfect condition and the control system wears out. Okay, the last little piece I'm going to try to get done today, in fact this is the end. Piece of tin can stock, and I want to make the little clips that hold the horn on. Now there's several good ways of doing this. Many people like to use nylon, brass. I like just plain ordinary tin can stock. Cut cut a piece out the size of maybe half a postage stamp. Relatively simple thing, just wrap it around, bend it. Pinch it with a pair of pliers. Set the clearance. You can just keep pressing it and twisting it, and you'll eventually get exactly the right clearance. Kind of a simple, straightforward thing. I'll trim this off with the Dremel tool. Make sure it's nice and free. Now the object, when you get these things pushed into the plane, you want to get them confining the horn that way, right up against the horn. Now I'll take this in on the parting wheel and just cut the corners off of this. Okay, the next session we'll be able to start putting the horns in the wings, but for now, it's been fun. Been a long day. Now what's funny is, sometimes the things you think are the least important, I don't know, somehow they turn out to be very important. I got a call from somebody yesterday. They were watching all the videos and sent them a box of videos. And they said the most important thing they got out of the whole set of videos wasn't really any of the construction things, but the sequence in which things are done. From step 1 to step 2 to step 3. And what he liked was the sequencing that I had for doing things. Now it just happens, one of the things I always like to do, if possible, I like to build a wing, and we're just going to be getting through before the end of this video on this. I like to get as much of the wing done. I like to get the controls in. And we'll probably finish that up today and get the controls hooked up. And then while this is, I'll get some dope on it. And of course some tissue. Now what happens is during this part of the construction, while dope and tissue are drying, coats of dope sanding, coats of dope sanding, while that's going on, I can be working on the tail. And if you follow through this sequence, you'll see it makes a lot of sense. Once I have the tail up to a point that I'm happy with it and it's drying, this will be ready for filler and sanding and silver. This will already be drying, and I'll start the fuse. And all the steps, the molding of the body and everything else, the things that I want to try to do. But you can see there's a logical sequence to things. The logical sequence always allows that something is drying, something on a workbench is at a point where it's drying or taken care as I'm working on the next thing. Because what other people do and have told me that they've run into is, I'll just give you an example, is they build a wing and they get up to a certain point, then they start building a tail, then they start building a fuse, and they go work on the controls, then they carve a top, and at no point in time, then they get to the point where they put a coat of dope on, bingo, and you're done for the day. You're finished. You get up Saturday morning, you put a coat of dope on a wing, you can't do anything else on the body, and you're stuck. So hopefully one of the things you can pick up off the video that'll make your modeling and your involvement in the hobby more enjoyable is the sequence. And I don't say my sequencing is the only way that works, but I know it works well for me and the people that seem to work in the shop here. Okay, today's job, what we want to do is I want to get the horn attached to the back of the wing. I want to cut a little notch in there, put a little razor slit, get the horn attached, get the push rod running down into the body. Now, when the bell, I better move this over. When the bell crank is in neutral, and this is something that's real important to have in mind. When the bell crank is in neutral, how can we show this? When the bell crank's in neutral, I'd like this to be in neutral too. I'd like all three things to line up at the same time, if possible. So that when I give it full up, I'm going to get, let's just say, give it about 30 degrees of deflection. When I pull full down, or vice versa, whichever the case may be, I get equal amounts. Doesn't matter if I have 28 or 32, but I want them to be equal. The one thing you mostly concerned with is you really don't want to have a deflection where one flap is deflecting. In other words, the up dimension is less or more. You don't want to have that. So we need an adjustment. The adjustment that I've used for many times is I'll run the end of the arrow shaft. First I'll bend the rod, I'll hold the bell crank in neutral and bend the rod where I think it should be, and bend that end. If that doesn't work out, and I need to make it a little shorter, I have a lot of choices. I can of course cut the wire, make a new end and wire, just replace the wire. I can do that several times, and if I'm not happy and I need a fine adjustment, what I can do is grind this out egg-shaped so that I have a very small amount of adjustment in here. In other words, looking from the side, I can move the wire back and forth, maybe to most a 1/16 of an inch, if not bend another wire. And by having that little adjustment front to back, I can fine-tune it. And I can work the controls up and down, make sure I've got the same amount up, same amount down. When I'm real close to having it, when I'm very satisfied that everything's happy there, I can fill this with epoxy or CA as the case may be, wrap this with some carbon fiber tape to keep it from splitting, and then solder on an eyelet on this end, and then that'll be the end of our controls. But the single most important thing I'm looking for here, and if you don't get it right now, for the life of the plane it'll be screwed, is to get from where the center line is on the wing, the neutral point, same amount up, same amount down, probably within 1 degree would be very important. Let's go over the bench and do it right now. Step 1 is, I have Joe's center line for the center sheeting joint, and I want to just verify that I'm exactly in the middle of the wing before I make any commitment to cutting anything here. So I'm using a triangle, I'm referencing off of that, and I'm dropping a center line down on here. This will just be for my own reference. Okay, now with that center line, now what I want to do, I don't have my big ruler here, I want to measure off out into each direction to make sure that off to this edge I'm exactly the same. 21 1/4, 21 1/4. That Joe knows his stuff. I'll give him credit for that. So that is accurate. Right there is the center line. Having that center line in place is very important. Now the first thing I like to do is take the horn, and where these little clips are is get a little drop of the PJ1. This is the chain lube material. Because what will happen if you don't get some of this in there, when you go to CA this to the back of the wing, what almost always happens is you glue the horn and the horn gets glued up in neutral, or wherever it happens to be when the glue hardens. The PJ1 is the material of choice here because it turns to grease. And when we install these, I want these pressed right up on the upright as tight as possible. So let me just work these in, make sure the grease is working its way in. Now if you get where they're binding up a little, just tweak it. Twist it one way or the other and you'll see. You can get any resistance. See how that is? That's what you want to have, is no resistance at all. A little tweak one way or another and you'll have it. This one is still binding up. There we go. Just the slightest tweak will get it open. Okay, with that free, now I need to mark where I'm going to have to cut this. And get that right on center. Let me mark this, the edge of the horn. And mark that. Now I'm measuring it from the edge of the horn, where I spot the horn. This is real important because if I had square tips, I could just shorten the tip a little bit, but because I'm locked into these little edges, I need to have the horn exactly in the middle. If the horn is offset one way or another, even by a 1/16 of an inch, it's going to mean an 1/8 of an inch difference in the amount of flap area. Now you can see the center line, the end of where I have to put the slit for the horn, and the end of where the horn arms are. So I have all the dimensions I need. I can get in and out and take a brand new 11 blade, cut a slit for these, push this in, and cut a little bit of a slot on the trailing edge. Again, this is one of the things I think a lot of people, this is where they get a little bit either confused or slow, or they just can't figure out how to get all the alignment. We don't want the horn to be crooked this way, or to be crooked in this dimension. When it's on the back of the wing, it's up like this or that. So we have 4 planes that we want that to be straight in, and at the same time it's straight, I want the upright to be in dead neutral when the belt crank is in dead neutral, all at the same time. The first thing is to get the slit in for the horn. Get a machinist ruler. It's the easiest to do, I think, with a machinist ruler. And make sure that it's dead straight. Try to line this up. Now, of course, the trick is to get that right on the center line, not to have it off. If that is off even just the least little bit, that horn will be in there just a little crooked and nothing will line up right. Now, before I even cut that hole, I want to get a center line on the back of this for the whole hinge line. And because Joe has the sheeting wrapped over the back, I can just reference off the sheeting with the edge of my finger and get a nice straight center line right down the whole trailing edge. I'm referencing off of the glue joints. So using this, normally when you have a square piece of trailing edge stock, you almost, you have to just hope that you have it right. This gives us a reference, because we're right in the middle of the 2 sheeting joints where the sheeting ends. And I can just, by using my finger as a guide, get a nice straight line on there for cutting the hinge pockets. Yeah, I just want to show that center line. And that's a good technique, using your finger. Got a center line down the whole trailing edge now, and I'll cut the little notch for the horn next. I want to also cut this little slot with a Zona saw here. Right in the middle. This will allow the horn to rotate. Again, I don't know why. This is one of the things when people come over here and they're putting a control system in, it seems like they get to a point where this is somehow either difficult to figure out or more time consuming than it should be. And just fold up some sandpaper and get that notch nice and clean. Now, if you just take a piece of 1/8 inch wire and along the whole length of where the horn is going to sit, walk it down the center line. That's going to be where that 1/8 inch wire rides. You're making a little press groove. You don't even have to carve it. You can just press it in. Just use the end of a piece of 1/8 inch wire that's got the burr taken off of it. Walk it back and forth a few times. Remember, the center of that horn has to be on the center. You can't have it hanging, this can't be hanging off the flap an inch to get the proper rotation. When you want those real smooth controls, you go pick up any of the expert level planes and the controls work almost by themselves. One of the reasons is everything is in alignment. There's no resistance anywhere. How easy that is just to get a nice notch in there. Now, if you have that picture in your mind, now you only have to dry fit the horn maybe once or twice, get any material out of the way that's giving it a problem. That sucker will be ready. Okay, what I did is a dry fit here. Press this in so you have the centers lined up nice. And now let's see how much more. I just have to take a little bit more out. Give the horn a little more travel, a little more clearance. There's that sandpaper. Again, you just take a little bit at a time so you don't wind up making a notch sloppy or any bigger than it has to be. And boy, you don't want to have this in any way off of center. This really is one of the key alignments. I want to get as perfect as I can. That should do it. Now I'm just using a little bit of slow CA here. Get this tacked into position. Make sure it's in good alignment while it kicks off. And the last thing, I can just, whatever's still liquid, wipe it with the Q-tips. And of course, make sure it doesn't glue the horn. Could ruin your whole day. Now, just to double check, this is tacked in. It isn't final glued in. I want to make sure from the hinge line with a 90-degree triangle, I have exactly 90 degrees. If these legs are pitched or bowed out, I'm never going to be able to slide the flaps on when I get the tubes in the flaps. Okay, that's real good. But if it wasn't, now you could tweak it just a little bit. Just grab it like that before it's in there permanently. Now I have that machinist ruler with some sandpaper on the back. I want to just get a nice clearance in here, and then I want to wrap this with some carbon fiber tape. Of course, I'll do the back side too. There's a nice, neat way to confine the horn. You don't want to leave the horn free floating. That horn is going to want to work its way off the back of the wing in time. Must be attached nice. The solider, the better, actually. And this is one way, just one way of doing it. I just want to put one drop of thin in there. Now that I have it in pretty good alignment. Now I got plenty of glue down in there now. Sanded it down so I have a nice ridge. I want to put a couple of strips of that Dave Brown carbon fiber in there now. I've got this wood hardened up with thin CA and then sanded down, so this is a lot harder than normal wood right now. Now, the easiest way is to just tack one side down, rub it with Q-tips, let it dry, and then we can wrap it around and do the same to the other side. Now you want to bend that as far down as possible, of course. Don't have to make this too fancy, but this will add a tremendous amount of reliability into the control system. If this joint loosens up somewhere in the life of the plane, the controls are going to be terrible. Just let that dry. Very, very nice way of doing it here. I've done it a lot of different ways. This way is always, well, it's reliable because it's never broken on me yet. That's the kind of ratio I like. Never. No failures. Let the Q-tips kick it off if possible, and then we'll sand that a little bit and bury it in thin CA. And be careful you don't get a carbon fiber splinter. That stuff is bad. Now you want to put some thin CA and harden this up the whole dimension, but you want to be careful not to get any, if possible, down into that horn bearing. That's why we put that chain lube down in there. Once you get some glue down in there, the controls never work right. Makes you crazy. Rub it with Q-tips, and as soon as it kicks off, you can see it's smoking already. We'll sand that down gradually. Don't let the Q-tip get stuck. And that will be nice. Give it another coat even. And that's mounted up there perfectly now. That's in there for the life of the plane. Now I want to get one drop of the chain lube right around the horn, and this is a good time to do it. Everything is sealed there with CA. One drop is all it'll take. Very capillary, it'll penetrate right in. Don't even need to wipe it. Make sure that joint, for no reason, gets any glue in it, any dope, anything. You want to have that horn in there as free as a bird. And that chain lube is the ticket. That's what keeps it nice and free. Just wipe whatever extra is off there. Enough of it always penetrates in. As soon as the liquid evaporates, it leaves a nice, like a wheel bearing grease. Well, it's the grease that on a motorcycle chain. Make sure that's nice and free before we go on to the next step. Now this is a good time. I want to get in there before I go any further and get nice grease the belt crank and the lead out. I can get in there right now with the PJ. Just put a drop of grease. Doesn't take a whole lot more on all the control bearing surfaces. Now what I'm trying to do here, I just press this in, not all the way because it's a pain in the ass getting it in and out. And I'm trying to find where neutral is on the horn and roughly where neutral is here. And you can see I put a black dot on the push rod with an ink marker. So I just want to make sure I'm real close so I have a little reference, a starting point for bending the wire. Now almost always you bend it too long, too short. You got to bend 3 or 4 of them, or you have to put the play in there. We'll see how lucky we are. Believe me, this is just luck. Getting this right on the first shot is amazing. Now one of the ways you can give yourself a rough estimate here is you can put the horn as far down as you expect it normally would go. Get the push rod all the way out and see if you're close. Push it all the way in and see if you're close. Now, what that's telling me is I need to make it a little bit shorter. If anything, it's going to be shorter than the line, so I'll move this up. Believe me, strictly luck if you get this on the first shot. Now we'll go over and see if this fits. If it doesn't, obviously what we'll do is cut the wire, first measure it, make a little template and know if we have to go a little bit shorter or longer, and go bend another piece of wire. If you don't do this right now, boy, later on, you're going to make yourself crazy. Now while I'm doing a dry fit here, I can see where the push rod is rubbing on the sheeting here, and I can adjust this hole accordingly. This can come out here a little bit. I don't want to have any binding to get this hole roughed in. You don't want any binding, obviously, on this push rod at all. Have most of the clearance here fine. Now we've got free movement now. Now I just want to make sure I have the same amount up and down and everything's in neutral at the same time. Looking at the belt crank and I can see it nice and clear. That's where neutral is. Now I can line it up. Well, it isn't off by too much. It isn't off at all, in fact. Now it still has a little bit. It has more down than up. So I need to shorten. Now, knowing that, I need to shorten the push rod, but it's such a small amount. I'm just going to pull this apart and elongate this hole just a little bit. That'll be the easiest way to do this. Now what I did, I looked at how much this was off. It was almost the thickness of the wire, so rather than elongating a hole that much, I decided to bend up some new pieces of wire. Believe me, you don't get it right on the first shot. This is, well, you probably do if you're lucky, but I'm not lucky. And you just got to keep going until you get that equal amount up and down, and bell crank neutral when the flaps are neutral. When all that happens, we'll be ready to install it permanently. Now, just to show you how unlucky you can be, I finally got one wire bent just right, and I made this the little stud that sticks up a little bit too short for my own comfort. So I went back and made another one. You know, maybe, I guess the lesson here, a good lesson is, or a good rule to follow is, if it's more or less than the thickness of the wire, you have to adjust. The thickness of the wire being 3/32, then you probably want to make a new wire. Less than 3/32, you can just elongate the hole. When I looked at this, I said, gee, I'm going to have to elongate that hole more than I want to. And I certainly don't want to put a big giant hole that you could, you know, pass a Tiger 60 through. Now we should be getting close to having the same, let's look at it this way. The same up and down. You really have to work it from the controls here. Yeah, I think we can live with that. Alright, I'm getting just a little bit here of resistance on this side. Again, just trim this a 1/16 at a time until you're happy with the clearance. Make sure it's not binding on anything before we sock this a little bit more. Nothing binding there, nice and clean. Same amount up and down. There's neutral right there. Now see, I can sight down these little flap partitions, these little tips. Now, same as on the push rod end, I'm going to wrap the end of this arrow shaft here with some carbon fiber. Just cheap insurance. Remember, all of this stuff, we're looking for the long haul. I'm looking for the thousands of flight airplane here. And cheap insurance, especially up by the little piece of the rod that sticks out. Just hit this with some thin CA and let it kick. Actually, I only had to cut, this is funny, I only had to cut 4 push rods to get one to fit. The one I do off camera will probably go perfectly. And I'll be wishing I would have videotaped that one instead of this one. And when I finish this control system, I'll run over and get the other one done off camera so that we can maintain both of the wings at the same level of completion here. Just let that kick now. A little sanding and then a couple extra coats of CA will make this nice business-like end. Now you can see what I've done to the end of the push rod. Put a couple of notches in with a parting wheel. That'll be for our safety wire. We'll hook this up to the horn, of course. Put an eyelet or a washer in here, and then wrap safety wire and silver solder it. It'll be a good redundant system. Also notice, all of the push rods always face out, so even if the solder joint was to fail, centrifugal force would tend to hold them in. Never bend the push rods in, always out. Now, I wanted to mention also, one of the things you can have a problem with without realizing it is if you bend this wire and the bushing is going in on this angle and the wire wants to ride either up or down, you build a bind into here. So what you really want to have is you want to be able to do this. Total free and well, I got to get back past the push rod, but no binding in that bushing at all. Now what you'd like to have is either a washer or an eyelet that fits relatively tight around the wire. The reason for that is when you heat the solder, it won't flow in and loosen up this bushing. You'd like to have as tight a fit as possible. I also want to take a little piece of SIG copper wire here, and this is our redundancy system. Go right into the notches, so even if the solder joint totally fails, you never have too much redundancy on this stuff. And don't forget to deflux the joint. And what I do is while that joint, let's heat the joint again, while it's cooling, move it just so it doesn't loosen up that other bushing. And after it cools, just deflux it. Now I'm going to get in there through this slot and grease the push rod right now, and then put just one drop of grease on here. Keep this from oxidizing if any of the acid has gotten inside. Always get the joint as clean as possible. The way you can tell if you have a great joint, a good joint, in good integrity, is the joint will be shiny. If it's shiny, you know it's relatively safe to assume that's not going to fail in service. And even if that failed, we have the wire, and if that failed, we have the centrifugal force pushing out on a push rod. Let's hope we don't need it. Now I'm just working at greasing. That's the whole idea here. Make sure there's no binding. Double check that everything is equal. Everything's nice and smooth. I'm going to have to run down to the shop. I get back tonight. I'm looking forward. I'll get the other wing done tonight off camera. Don't even bother with it. If you can steal from this video just this much of the control system having good alignment, good integrity, and good longevity, you will be way ahead of the game on your next plane. So I hope you're picking up at least some of the theory, some of the ideas. You may even have better ideas, but some of what goes into doing it. This way has worked very well for me. Seems to always get me into the top 5. Planes seem to last 10, 15 years. I feel confident in using this system on future planes, and of course confident that Joe will have good success too. So I'll put this wing away, run down to work, and I'm out of here. Amazing, I got both of them done. I am really impressed. Adamusco, you better be impressed. Now we're going to come back tomorrow morning bright and fresh, I hope, and ready to work. These suckers moving. And tonight I don't have a lot of time, but I want to frame out what I hope will be the flaps, at least get the rough work done on the flaps. The way Joe's cut these, he's framed them out, but he's just put a slight taper in them. He has a fixture to do this, so very nice. Obviously it's a big help. So step one is I want to measure where the horn is. Do one at a time here. Get a nice tight fit. measure where the horn is. Of course, once one flap is done, it'll only go back into one position. So. Now with that, where's my triangle? That's exactly where the horn is going to go. I just want to mark this off. That's where I'm going to have to sink in the tube. Now we're ultimately going to make some kind of fancy fillet here, so I'm just going to put that wood back on when I'm finished. First thing I want to do is get a center line around the whole flap. Using the old technique, walk it down on your finger. If you haven't mastered this yet, it's a good thing to do. Use some scrap wood. Using the edge of your finger, you can just get a center line down the thin edge of wood without holding a ruler. And the reason it's better than doing it with a ruler is if you have a ruler, what'll happen, a lot of times the wood will have a bow and you'll be putting a crazy center line in. This gives you a center line relative to the edge of the wood. I want to center line the back of this. I want to do all the rough cutting first. And then I have to decide how I'm going to get that tube in for the horn. The object of all this is I want to be able to put the flaps on and off right up until the time that the plane is buffed out. I don't want to have the flaps on permanently by doing it that way. One of the reasons is we're going to have a camouflage paint job of some kind, and I want to be able to paint right up to the middle of the hinge line, right up to the edge. I also want to be able to paint in by the hinge line. I also want to be able to buff the parts out individually. So like Strager and like Tsunami, I want to have the flaps and elevators detachable right to the very last minute. Now once I have a center line that I can reference off, I want to take some 1/8 inch tape, lay out a piece of 1/8 inch tape right on the edge of the flap. 1/8 inch is just about right. These are 1/4 inch sheet flaps. Obviously, if you have thicker flaps, you might want to go to thicker tape or leave the tape just sit back just a little bit. Put the first piece on, put another piece right along the edge. It's really starting to get to be winter out there. It really froze at work today. Okay, you get the second piece on just butting up to the first one. Press it down nice. Take the original one off. We can use that piece again. And you've got that piece laid out. I'll flip it over. Take the original piece. Do this on both sides. If it isn't sticky enough, I'll have to use a new piece. Now, I have some ideas. Bob Martens a year ago suggested a good way to put hinge pockets in, and I think I'm going to give it a try this time around. I'm going to think about it tonight. Maybe jig it up tomorrow so I can do all the hinge pockets with a little fixture. Something I've been thinking about for a couple of days. Again, Bob Martens has given us many good ideas, many good tips. He's been a very real part of the program for a long time. After about 2 times, that doesn't have enough glue. Now you have a perfect edge. You can work off this. Now, if you really wanted to, you could put some tape down here so you were going tape to tape, but I really don't think that's necessary. I can carve this with a knife relatively conveniently. Now, if you notice, this is C-grain wood, and the grain is going parallel to the trailing edge, not the hinge line. So one of the things you would not want to do is go from this end of the flap to the big side, or you'd be catching a grain and the knife would be digging in constantly. You want to go with the grain, not into it. So one of the things I want to do is line it up right with the edge of the table. Brand new blade, of course. And the trick here is kind of eyeball up the edge. Try to get within a 64th if you can. Try to get it off in one piece if you can. We just went in a little too far here. This wood does have some hard spots. Get as much of it off as you can in one shot, and then I'll block sand the rest right down. Now I may have to go back here. And this is something you almost have to do on every plane, whether it's a Nobler Old time, new time, whatever. Again, this is a good technique. The 1/8 inch tape works extremely well. Now, if you're doing an elevator, of course you want the tape back a little further than 1/8 of an inch. Now when you see you're starting to work your way into the pencil line or the pen line, it's time to just back off, and when you see you're rubbing into the tape itself, get an idea for the first cut. Now of course we'll just make the second cut, flip it over, and work in the opposite direction. Now when you flip it over, you have to spend a little bit of time just watching it. You don't go into the center line. You probably should take the cuts just a little bit slower on the opposite side. Good tricks are to use a brand new blade and move the blade. Don't try to hold the blade in one position. Let the blade constantly move down the edge of the blade. Any kind of carving, that seems to be a big help. And don't skimp on new blades, whatever you do. Use a nice big long sanding block, the longer the better. You can usually get this in one or two shots. The last thing I want to do, I want to dress that edge off, and usually we just have the thickness of a pen line there. Pull up the tape. And you should have a really nice edge. You get a relatively nice edge with very little labor. Now I want to clear off this corner of the table. I want to work on this edge here. Remember, I always want to go with the grain. I just want to cut the corner off, using my finger as a little bit of a dead stop. Sometimes I can get this off in one shot, not always. This wood has hard spots. I get my money back from Joe. I'll just break the edge with the knife and do the rest with the sanding block. Now on this kind of a job where you have to make 4 flaps, any kind of little shortcut you can use to make them either nicer or quicker or cheaper or whatever, every little step is a big help. Okay, I got one of the flaps already radiused out. I'll let this one go. I just want to do one on camera. I want to cut this right now. Make sure I have the tip. I want to slice this piece off and insert the tube that I'm going to have so I can slide this back and forth. Now at this point, one of the most important things before we even go any further is to make sure this cut, I'm checking it with a 90-degree triangle, is exactly 90 degrees. If it isn't, if this is off this way or this way, what's going to happen when you go to slide the flap onto the aluminum tube, it'll either ride up or ride down or have some kind of cockamamie angle. So before we go any further, check with a 90-degree triangle, and that looks pretty close. Now I'm just lining up the flap, measuring up the horn here. Okay, no, that's how far in the tube has to go into the flap, and I can just mark that up. Now what I'm going to do is get a Dremel bit with a little bit over an 1/8 inch radius and Dremel out a slot in there. Now I hope you can see the way this works. I'm trying to do this through the macro lens, of course. That piece just plugs right in. And then we have to check, most of all, for our 90-degree angle. Very important to get that 90-degree angle just right. Now again, before I even tack glue this in position, I want to see that it's 90 degrees. Make sure it's not wandering off one way or another. That looks pretty good. Make sure it's in all the way. Now we have to just tack gluing it just to make sure before we go in and permanently glue it. Sure we have 90 degrees. Okay. Now with that tube set right in and tacked in, I'm going to harden this whole edge up with thin CA. Just let it kick off naturally. That'll lock that tube in and I'll check it again. Phew! Now the next step is I have to cut this back so that the bend of the wire can snake in there. Just put a little U-shaped grind in there with the same tool I used to cut the groove. And what that does, that just lets the wire drop right in there. Now I just want to dress this edge off, and then I want to put the piece back on that we sawed right off. Just butt joint it. And that tube will be set right into the flap. There's almost no other way I know of that you could drill that straight, make sure it's straight this way and this way, all in the same plane. This is really, and we're going to glass over this or double tissue it one or the other. Now I'm just going to take that piece, get it lined up as closely as I can. Always tack it first. Make sure it's a nice straight joint. Of course, you always glue it to the table too. That's the other fun. Okay, let that dry. Flip it over. Using the table for alignment. A couple of drops. Now I want to take some real fine sandpaper. Use one of the blocks. And let that crack fill up with sawdust before you hit it with the real CA, assuming that it's nice and straight. Wipe it with a paper towel. Flip it over, same thing. Let that all fill up with sawdust. And the next thing I have to do, I have to notch this just in front so that there'll be a little pathway for the music wire to horn to go. And then final sand that joint out. Now I just hardened up all the edges with thin CA. This joint is kind of nice and sanded in. See, now we could have sunk the horn in the end with plywood like we normally do. The only problem with that is I don't know how Joe wants to curve this. He had some idea he wanted to curve this to make a semi-scale fillet. I don't want to make a commitment with the horn here. I can go either way. Now I have one flap finished and of course 3 to go. What a thrill. This one is finished. I'll pick this up. Actually, we're at the end of this tape. I'll pick the rest of this up off camera. Make the other 3 flaps up, and I don't know. I guess we'll be closing in on having this wing ready to do the final sanding out on. Well, I only got 1 flap done tonight. I'm gonna have to work on the other one tomorrow. But this is the end of the tape. I'll finish that up off camera in the next session. And when we come back here, we'll be ready to put the hinge pockets in, and I want to work on it. A little bit of the Bob Martens thing for putting the hinge slots in. So, see you on tape 4. Spitfire.